Okay, in 1.3, we're doing an introduction to experimental design. So they give you a plan of setting a statistical study, all the steps you have to go through. So you see, we've already talked about some of these things. So you need to identify the individuals, which we've talked about what that means. Specify the variables and how you will take measurements or make observations. Determine if you're going to use an entire population or a sample. If a sample, make sure you use the correct method. So we have already talked about individuals, variables, sampling methods, all those. And your data collection plan address issues of ethics, subject confidentiality, and privacy. We're going to collect the data, use appropriate descriptive statistics, and make decisions using appropriate inferential statistics methods. And then note any concerns you might have about your data collection methods and list any recommendations for future studies. So this is kind of the plan you follow if you're doing a statistical study. It's not going to be very important for us throughout the semester, but I want to make sure you see that it does help to know what you're looking at, know all of your parts of the study, so then you can make your decisions later on about that study. When we get into chapter 7 and 8, we're going to do more coming up with what we find in a study. We won't have to identify everything. It will already be given to us, but we're going to actually use the appropriate methods to describe what we find or what we deducted from the study. Now, a population representative sample, a census uses measurements or observations from the entire population. It's better if you have a smaller or easily accessible population. A sample uses measurements or observations from part of the population. This is better for larger populations. Now we've got observational study versus an experiment. Observational study is when observations and measurements of individuals are conducted in a way that does not change the response or variable being measured. In an experiment, a treatment is deliberately imposed on the individuals in order to observe a possible change in the response or variable being measured. So when you are doing an observational study, you're just observing. Nothing changes. You're observing things, you're collecting data, but you're not changing anything of the study. Now, your treatment group is the members that have a treatment applied and the variables measured, whereas your control group in an experiment, the members receive a dummy treatment and the variable is still measured also. So in example 4, we have the silver sword plant that once grew abundantly in Hawaii seemed to be growing less and less. Biologists expected that goats were partially responsible for the decline in the number of plants and conducted a statistical study to verify their theory. The scientists set up stations in remote areas of a national park. At each station, they had 2 plots of land that were very similar. One plot was fenced to keep out the goats, while the other was not. At regular intervals, a plant count was made in each plot. Was the study an observational study or an experiment? If it was an experiment, what was the treatment that was presented in one plot but not the other? So this is an experiment because they're doing 2 different plots. They're changing something in the other plot. So our treatment then is the fence around one plot. Now they want to know then which would be the control plot. So the control plot was the one that nothing happens to it. So that's going to be the plot that was not fenced in. Now, in these experiments, the placebo effect might occur. And that occurs when a subject receives no treatment but incorrectly believes he or she is in fact receiving a treatment and responds favorably. A person feels better after taking a sugar pill, for example. A completely randomized experiment is one in which a random process is used to assign each individual to either the treatment or control group to prevent bias. A block is a group of individuals sharing some common features that might affect the treatment. So, for instance, men and women. So if you do a randomized block experiment, the individuals are first sorted into their blocks, so like first sorted into the men and women categories, then they're randomly put into the control group or the treatment group. So example, before grouping individuals into one of two exercise programs, block the individuals into weight categories. A lurking variable is one for which no data is collected about it, but it has influence on other variables in the study. So for example, in a study involving amount of gasoline used to commute to work and time to commute to work, the level of traffic congestion is a lurking variable that would increase both variables. However, it's not a part of the actual study. Confounded variables are when the effects of one variable cannot be distinguished from the effects of the other. Confounded variables may or may not be a part of the study. So an example is a study involving GPA, difficulty of courses, IQ, and available study time. Some of the variables may be confounded. For example, students with less study time might take easier courses. Replication of the experiment on many patients reduces the possibility that the differences in the two groups did not just occur by chance. Double blind is when neither the individuals in the study nor the observers know which subjects are receiving the treatment. Okay, so we just went through a couple different terms here. I want you to stop the video. I want you to look at these four and tell me if you think it's a sampling, experiment, simulation, or a census. So you should have paused the video and all of your answers should be written. So we're going to go through it together now. So for A, it says study the effect of stopping the cooling process of a nuclear reactor. Now we want to think about this one. We don't really want to go sample or do an experiment with it. So we probably want to do a simulation so we don't have to actually be there exposed to the nuclear reactor. For B, study of the amount of time college students taking a full course load spend watching television. That would be easily done with a sampling, because you can sample students. For C, study the effect on bone mass of calcium supplement given to young girls. So if we want to study this and see the effects of it, that's going to be more of an experiment. Then for D, study of the credit hour load of each student enrolled at your college at the end of the drop add period this semester. So if it's every single college student, we can get all of that information from the registrar's office. So that's going to be a census because we can actually look at everybody.